Hi everyone, Miss Pellone here. Welcome to week 3 redox lesson that we would have done if we had our period tomorrow, which we don't. Okay, so one thing you need to know before you start watching this is you need to have with you these 2 redox titration worksheets during this lesson. This will be a virtual lesson, but I'll ask you to do things in between, which I'm going to assume you're doing. Okay, so see the one on your left, redox titrations in the bubble writing. I want you to complete up to volumetric analysis involving redox reactions by yourself, as it's Year 11 revision, as much as you can do before you watch this PowerPoint. Okay, so you should be pausing it now and trying to do that. Alright, so I hope you guys went well on that redox titrations worksheet, and let's move on. First of all, here you can see my nice little GIF animation. A reminder, this PowerPoint is online if you guys want to download it and use it during this lesson. Okay, so what I would have done in class is showed you that typical reaction between magnesium and oxygen in burning magnesium with a Bunsen burner. And can everyone remember the type, what happens to magnesium? Yes, that's right. So it actually goes, it actually releases UV light, and that's why it's not good to look at it. But yeah, so basically it's burning in oxygen. So let us write out this reaction. This is a brief intro to redox reactions. So we have our magnesium, solid, plus oxygen, gas, produces magnesium oxide solid. And of course that is not balanced, so we add a 2 to the magnesium and a 2 to the magnesium oxide. So here in actual fact we have a redox reaction. Now so how can we find out which is oxidized and which is reduced? Correct. Oxidation numbers. Okay, so we know that 3 elements have an oxidation number of 0. So we know that magnesium will have an oxidation number of 0. Now the way I always keep track of oxidation numbers is I write down the oxidation number of each element at the top. So magnesium has 0. And the total number at the bottom. Now, because magnesium, there's only one of them, it'll also be 0. Oxygen is 0, free element, times 2, 0 times 0 is also 0. So that's no problem. But magnesium oxide, we have 2 negative. Oxygen always has a 2 negative charge, unless it's with a peroxide. And magnesium will have a 2 positive charge. So magnesium has risen from 0 to 2 plus, meaning that it is what? Oops. That's right. It is oxidized. And oxygen has gone from 0 to 2 negative, meaning what? That's right. It has been reduced. Very good. Redox reactions. Quick revision of redox. Reactions that involve the transfer of electrons from reductant to oxidant is called a redox reaction. The species that has gained electrons has been reduced. Remember, the species that has gained electrons has been reduced in oxidation numbers. That's why it is called reduced. The oxidized species has risen in oxidation number and has lost electrons. so it's been oxidized. The reduced species has lowered in oxidation numbers and has gained electrons. Oxidation and reduction occur simultaneously. This is important. Where are the electrons going? We can't just spit out electrons. They have to go from one species to another. What do they go from? Oxidant to reductant, or reductant to oxidant. Okay, so here's something that you can do to remember where they come from and who they go to. Oil rig. Oxidation, so something that has been oxidized has lost electrons. Oil. Oxidation is loss of electrons. Rig. Reduction is gain of electrons. Think about this. This is the way I think about it. The oxidant itself has been reduced, but it has oxidized others. The victim has been murdered by the murderer. Right? The murderer is a murderer because it murders others, and the victim itself has been murdered. Are you laughing? Okay, next slide. Oh, okay. So, a way you can also remember which one's more likely to become oxidized is metals want to lose electrons. Remember, they only have a small number of electrons in their outer shell. They want to become stable, so they tend to lose electrons, becoming oxidized themselves. Okay, and here is just a flow chart which you guys can use. Alright, so this example is a very good example. We're going to go step by step, but I'm going to give you, well, I want you to actually pause the YouTube now and try and answer these examples on your own. Which of the following are redox reactions? This is a typical exam question. For those that are, indicate which element is oxidized and which is reduced. For those that are not, indicate whether they are precipitation or acid-based reactions. Acid-based, sorry. So give yourselves a little while to do it, and make sure you press pause, press play when you're done. These are on the lecture slides. So for the first reaction, we have copper hydroxide plus nitric acid makes copper nitrate plus water. Okay, let's have a look at what is being oxidized and what is being reduced. Okay, I'm going to use a different color pen. Now, what we can do is start off with sort of the easier parts. So, I would start off with nitric acid here, just find it really easy. We always know that the oxidation number of oxygen is 0, not always, but in this case it will be, -2. We know that the oxidation number of hydrogen is 1. Now what I was talking about below is to help you keep track of the oxidation numbers so you can work out this middle one here, which a lot of you found trouble with in the Head Start. So what I do is I have +1 at the top, and basically the charge of the whole molecule equals 0. We know that because it doesn't have -2 or anything there. So we have to make sure that the oxidation numbers equal 0. We have +1, and we have 3 oxygens at a -2 charge, -6. And then we have X here. So 1 plus X minus 6 equals 0. It's obviously +5. So we know that the oxidation number of nitrogen is +5. Okay? Now, copper's oxidation number. Copper in this case has a +2 charge. We know that because the hydroxide ions have a -1 charge. So copper is 2+. And a quick way that you can do it, I mean, I wouldn't have even done all of this because after a while you'll realise that copper has a 2+ here, copper also has a 2+ here. Nitrogen you can go by, or yes, nitrogen you can go by. Now, nitrite has a charge of NO3 negative. Okay? So oxygen will have a charge of 2 negative times 3 equals 6. 6, so negative 6 has to equal negative 1 altogether. We know it's 5 minus 6 is negative 1. Nitrogen doesn't change, copper doesn't change, O doesn't change, H doesn't change. This is in fact not a redox reaction. Now, instead of having to do all of that, working out the oxidation number of this and that, we could easily just look at the reactants and go, ooh, OH, there's a base. And nitric acid, there's an acid. And then we produce a salt. See how it swapped partners and formed a salt, and a water. That's a telltale sign of an acid base, not a redox reaction. But if you had to prove it, you would have to write the oxidation number of everything there. So this is in fact an acid-base reaction. Now for this next equation, automatically, because I've done enough redox reactions, I know that this is a redox reaction. How do I know? Well, I would start off with the easiest ones. Fe is just a pure element which has an oxidation number of 0. Right? So altogether that's 0. Now, let's move over to the Fe over here. We know oxygen has a negative 2. The entire formula has to equal 0. The oxidation number of everything has to equal 0. So we can go negative 6 for oxygen. And then we have X times 2 minus 6 equals 0. And we can see that it is 3 times 2 minus 6 equals 0. So iron will have an oxidation number of plus 3. Making sense? Good. So now we have carbon dioxide. Let's have a look. We can already see that it has changed. But let's have a look. So oxygen, negative 2. That's all equal 0. And carbon is positive 4. Oxygen, negative 2. So negative 2 here and plus 2. We can see that Fe in Fe2O3, you need to be specific like this in the exam, because sometimes, well, probably not for this one, but sometimes there are multiple, the elements exist in many different formulas. So I'll show you an example of that later. But Fe in Fe2O3 goes from a positive 3 to 0, so it has been reduced. Carbon in CO has gone from a negative 2 to positive 4, so it's been oxidized. Very good. Okay, moving on to the next one. Now, for this next one, there are a few telltale signs, right? Basically, we can already look at it. We know that we have strontium with a charge. First of all, we know the charge of